Okay, so I'd like to go into one more thing about the instancing, and that is creating large groups of instances, which is, I mean, obviously where instancing the advantages come in handy is large groups because of their low memory footprint, but using particles to do this. So if I actually go into the Explorer, let me just grab here my ground. What I like to do is I have these two models of trees, okay, and I've now put them inside a group that you'll find here. And basically, I'm going to use one particle type to, for every single particle, create an instance of one of these two in this group. So you could put as many objects into there as you want with animation, with everything else, and it'll then, for every particle, pick one of these to put it on. So obviously we need my particles, and what I've simply done is used the grid as an emitter, but without any speed on the particles. So if I go into my particle cloud, you'll see on the p-type, the last tab here is instancing, and what I have to do is I have to enable it and pick an instance group, which is this one here with both of our trees in it. And you'll see that it immediately now draws, I have the OpenGL on bounding boxes, so it draws a tree on every single particle along the grid. Now the advantage is, of course, because the tessellation isn't required for every single tree and they have a very, very low memory footprint, I can easily render all of these trees very, very quickly. There you go. And if I wish to change the original trees, maybe, I don't know, make a sort of a space tree with a big pointy bit, or we're increasing it into a monster tree, there we go, using our proportional falloff, and then we just render this, you'll see that it immediately changed all of them. Yeah, the instance then are driven by the original in terms of modeling and animation and everything else. Okay, the other thing is, of course, that because instances can be scaled, rotated, and translated, as long as the topology is not changed, I can also, for example, inherit rotation from the particles or the scaling from the particle sizes, so that then if I wish to maybe destroy my forest with rotation, there we go, we'll just create a randomness on the whole thing and play this off. We can see that my forest is then whirling around in a hurricane or something like that. But anyway, you can now create large masses of objects that are controlled then by the particles. And because, of course, our particles are objects like everything else, if you decide there's one tree in there that you just don't like, you can simply select your particle cloud. It's a little bit hard to select there. There we go. Just grab it and maybe select the point and just delete that one. Or maybe we want a bare spot right in here and just delete all those particles, and you'll see that then there are, of course, no trees there. So it's very, very easy to control exactly where you want something or where not.